Sorry about the last part of the last video, but let me do number 17 real quick for you, and I'll do it a little bit slower. It says water flows at a constant speed of 16 meters per second through a narrow section of the pipe. What is the speed of the water in the section of the pipe where the radius is twice that of the initial radius? So you need this equation in order to understand it. This is the continuity equation. The area of the first part of the pipe times the speed, so the cross-sectional area times the speed of that fluid is equal to the cross-sectional area of the new section of the pipe times the new speed of the fluid. So if we're doing twice the radius, you have to understand that the area of the cross-sectional pipe is going to be pi times r squared. So if you double that radius, the double gets squared, which means it's actually a times 4. So that means that we're going to actually have 4 times the area. So therefore, if I multiply this side by 4, and this is going to stay constant, then I have to divide this side by 4. So if this original speed is 16, then this speed is going to be 16 divided by 4, which means that I'm actually going to be going 4 meters per second. So it was originally going 16, it slows down to 4. So the answer is D, 4. For number 18, it says Venturi tubes have 3 sections with different radii. Which of the following true about the manometer readings? Manometers are pressure gauges. And if you look at that picture there, you can see that the thinnest part is at P2, the next thinnest is P1, and the biggest is P3. You guys should understand that the thinner the pipe, the faster the fluid's going to flow. And so let me write this. Thinner means faster, and that's from the continuity equation. That's how we know that that's true. And then Bernoulli's principle says that faster fluids means lower pressure. So that means that P2 is going to have the lowest pressure, then P1, then P3, which means that the answer is C. The last 2 problems are not on the quiz, so we won't go over those. All right, so here are the problems, the practice problems, and I'll just go by section. I'll do maybe 1 or 2 problems from each one. For the first one, density and specific gravity, the main idea here is the density equation. Rho, which is a Greek letter, stands for density, is mass over volume. I'll write this in words so you can see this. Density is equal to mass per volume. So just what is the density of an aluminum block with a mass of 4,050 and a volume of 1.5? So you would just plug it in. So 4,050 divided by 1.5 gives you the density. You just punch that in the calculator and you get 2,700. And that's kilograms per meter cubed. That's the unit for density. All right, so that's number 1. Actually, I forgot I can scroll up on this. Oh, let's see. What's the mass of a rectangular shaped ice block with dimensions if the density is blah, blah, blah? So again, same equation. They give us dimensions. So in order to find volume, it's length times width times height, right? So that's 0.04 times 0.05 times 0.03. Punch that in your calculator. And you get 6 times 10 to the negative 5 in your calculator. That's the volume. And then you're looking for mass. Now here's the thing. The density is 917. And the mass is what you're looking for. And you have 6 times 10 to the negative 5. To get m by itself, you have to multiply both sides by 6 times 10 to the negative 5. That cancels that out. And then you have to multiply this side by 6 times 10 to the negative 5. So 917 times that is 0.055, and that's kilograms. So that's number 2. The last one I want to show you, because this has been coming up a lot, is let's look at the number 3, which is what is the volume of a wooden board with a mass of 0.6. So again, equation is this. What is the volume of a wooden board with a mass? So we have a mass of 0.6 and a density of 900. So a lot of my students have been saying, okay, multiply this side by 0.6 and multiply this by 0.6 and you get the answer. That's not algebraically correct. If you multiply this side by 0.6, that doesn't cancel that 0.6 out. That's not how math works. So instead, what you have to do is, it's 900 equals 0.6 over v. I think what's been helping a lot of students is just to say, all right, put that over 1. And then I think that just solves all of your problems somehow. And then you guys cross multiply, so it's 900v equals 0.6. And then v, you would divide 900 by both sides. So it's 0.6 divided by 900, which the answer then becomes 6 times 6.6 repeating times 10 to the negative 4, and that is meters cubed. All right, so that's density. Yep, and that's where I'm going to stop.